Hi, I'm Pat Kelly. This problem is going to take 2 videos, so at the end of the first, stay tuned and we'll finish the problem together in the second video. Okay, got our work cut out for ourselves here. They give us a function, this g of x, and they really ask us for 3 things in the directions: to find the relative extrema, find the points of inflection, and then also we're going to use our graphing utility to confirm our results. Okay, so let's do a piece of that at a time. Now, if we're going to jump in and try to find our relative extrema, this is an older idea, but you should remember relative extrema can occur at those critical points. So I need critical points. You should remember to find critical points, you need the derivative. And that's why this problem is in this lesson, because we're learning about the derivatives of these exponentials. Okay? Now that 1 over the square root of 2 pi is just a constant, so when I go to differentiate, I'm just going to rewrite it. It carries down. And I'm focusing on differentiating that exponential expression. Now the trick I would use here every time if I'm differentiating any exponential is it always spits itself right back out. So whatever you're looking at, no matter how complicated it is, it will be a part of your derivative answer. Okay, that's just a start. Then you have to differentiate just the exponent. Okay, so I need to tack on with multiplication the derivative of just this exponent. So let's do that now. The first thing I see up in the exponent is that there is a minus sign. So when I differentiate, that's a coefficient again, so there's going to be a minus sign. I'd really like to stick that out front here. So I'll switch colors in case you're looking back at this. This minus sign is coming from me differentiating that exponent. Okay? Package it with my coefficient up front. Now here's the rest of that derivative of the exponent. It's something raised to the 2 power, so the 2 comes in front of that. Notice that's going to divide with this 2. That'll be convenient for me. And then that x minus 2, that something that was raised to the 2 power, is going to drop down to the 1 power. Then I need to multiply by the derivative of what's inside, and the derivative of x is just 1. So there's my derivative. Okay. Now what I'm going to do is try to follow through with the first part of our problem where they're asking me for relative extrema. So this will be my relative extrema work. And then when we're done, we'll go back and find those inflection points if there are any. So relative extrema can occur at critical points. Critical points come from your derivative. So let's find critical points. You don't mind me abbreviating critical points. Critical points could be where the derivative doesn't exist, or could be where the derivative equals 0. Okay. Now the first one that I mentioned there, the derivative not existing, is not an issue here. Okay. I know it's kind of involved looking, but the first chunk of it is just a constant. I'm not worried about that at all. The next chunk of it is this exponential expression, e raised to a power. We'll never have the issue of being undefined. Okay? Your graph of e to a power, e to the x, always stays above our x-axis. So there's never any division by 0 or anything. So that's going to be well behaved. And finally, the last chunk of it, that's never going to have any division by 0. So I'm not worried about critical points here where the derivative doesn't exist, because the derivative is always going to exist. Next thought is the derivative equaling 0. I'm going to go through my chunks again. The constant's never going to equal 0. The second chunk is an exponential. That also will never equal 0. Okay, so that's not going to give me any critical points right now. The only critical point comes from the third chunk, x equals 2. That's the only place the derivative can equal 0. Okay, all that thinking just for that one value of 2. Now what I do with that is, if you're remembering your first derivative test, I like to visualize it on a number line when I do my first derivative test, plot that critical point, that value of 2, that x value of 2, and then you test on either side of the interval. And when you do your testing, you're going to be plugging into the derivative. So I will pick my favorite number to the left of 2, and you can pick anything you want. Once you pick it, we're talking about plugging and chugging into this expression. Don't panic. Here's my thought process. You don't even need a calculator. I'm going to pick a 0. 0 is always nice, but my thought process is You only care about whether it's positive or negative. So let's break down the chunks again. These chunks are factors. So this factor is my constant factor. It's always negative. So I have something negative times, and now I'm plugging in my value for x, but this second chunk is that exponential again. E raised to anything is actually always going to be positive. So this chunk is positive. And now that final chunk, when I put my 0 in, 0 subtract 2 is negative. Now, since these are all multiplications here, these are all factors, I'm going to have a negative times a positive times a negative, which will result in a positive overall. So with my first derivative test, I've just found that that interval will always yield a positive result in the first derivative. Now the second interval, anything you want to the right of 2. So if I grab a 3, I'm using my same thought process though of this chunk always negative, this chunk always positive. Now this chunk I have to pay attention to and plug in my 3. 3 minus 2 is positive. So negative times positive will be negative. So my first derivative test gives me that result. And what I further do for a visual is plus means up, increasing function, minus means down, decreasing function, and then you can see that you've just created a hill. So I have a relative max at. All right, now, relative max at, and my little landscape here that's shown me the hill tells me that that's happening at 2, but that's your x value. So I'm going to start an ordered pair here and put 2 comma. To find your y value, you do have to take that x value, and let me walk over here, plug it into the original. All right, so we're talking about plugging a 2 in here to the original. Still might look like a tall order, but it's not. Let's plug the 2 in for x. 2 minus 2 up there is 0 squared, still 0, divided by 2 is still 0. This boils down to e raised to the 0 power. E to the 0 power, you should know this without a calculator, that's 1. Times that coefficient in front, and my result here for my y value will just be that 1 divided by square root of 2 pi. And I'm happy with that. I don't need to go to a calculator and get a decimal. It's a good answer. Okay? Okay, thanks. Now stay tuned because we're going to finish the problem in the next video.